Okay, question 4, they ask us to show that the equation x to the power of 3 minus 4x squared plus 2x plus 1 equal to 0 has a root between. This one you have to change, it is -1 until 0. And using a Newton-Raphson method with the initial approximation x naught equal to 0, find the roots correct to 4 decimal place. Okay, first step is we have to check whether there is a change or not in the sign between -1 until 0. So we have to substitute first. Our fx is equal to, right now, x cubed plus minus 4x squared, okay, plus 2x plus 1. And then here you have to substitute when x is equal to -1 inside the function fx. So -1 cubed minus 4 minus 1 to the power of 2 plus 2 multiplied with -1 plus 1, you're going to get equal to -6. And then f, substitute x is equal to 0 inside, 0 cube, this is supposed to be cube, minus with 4 multiplied with 0 plus with 2 multiplied with 0 plus 1, you're going to get equal to 1. So by right, this is less than 0, this is greater than 0. So by right, there is a change in the sign. So that means there is a root between -1 and 0. So here you can write there is a change in the sign. That means there is a root between -1 until 0. So from here, what we have to do is we have to differentiate fx because we will apply into the Newton-Raphson method. Okay, so differentiate fx, you're gonna get equal to 3x squared minus with 8x plus with 2. Okay, then we will apply into Newton-Raphson method, so which is xn plus 1 equal to xn minus with fx and divide with f prime x to the power xn. Okay, so where xn is the value of x that you get for each of the iteration law. Okay, now we'll go to the next page so that easier for you. Now we will list down first all of the value that we have here, which is our x naught is equal to 0. Okay, our fx is equal to x to the power of 3 minus 4x squared plus 2x plus with 1, and then our f prime x is equal to 3x squared minus 8x plus with 2, and our formula is xn plus 1 equal to xn minus with f xn divide with f prime xn. Okay, so the first step is, what you have to do is you have to keep substitute inside this formula, and then you're gonna stop when the two successive approximation have equal value. By right, let's say when you reach x is equal to 7, you get equal to 0.4999, and then on 4980, let's say, and then the x equal to 8, you also get the same value. Then by right, you have to stop, do the iteration law. Okay, so that is the roots. Okay, now I proceed, because we already have x is equal to 0, I will proceed to x is equal to 1, which is you're going to get x0 minus with fx0 divide with f prime x0. Okay, x0 is 0 or x naught. fx0 you should substitute inside fx. So 0 cube minus with 4 multiply with 0 square plus with 2x plus with 1 divide with f prime x to the power x0, which is you have to substitute inside f prime x, which is you're going to get 3 multiply with 0 square minus 8 multiply with 0 plus with 2. So from here you will get 0 minus with negative 0.5. So here you're going to get negative 0.5 for x1. So you have to do this process again and again for x to the power for x2, which is here you get x1 minus with fx1 divide with f prime x1. So your x1 that you have is negative 0.5, right? So you substitute negative 0.5 minus with fx1, this is your fx, substitute x is equal to negative 0.5 in each of the x that you have. So negative 0.5 cube minus with 4 multiply negative 0.5 square plus with 2 multiply with negative 0.5 plus with 1 divide with f prime x1. So you use f prime x here, substitute x is equal to negative 0.5, which is 3 multiply with 0.5 square minus with 8 multiply with negative 0.5 plus with 2. And you calculate here, you're gonna get equal to negative 0.5 minus with negative 1.125 divide with 6.75. So you will get the answer is equal to negative 0.333. Then you're going to use the same value of x2 into the x to the power x3, which here you're going to get x2 minus with f prime, fx2 divide with f prime x2. So you will proceed to the same value, where here you're going to get x2 is 0.3333, and then minus we substitute inside fx and f prime x, you're going to get minus with negative. This one you calculate on your own, yeah. I don't think I should show to you because the step is very long to show. Make sure you calculate properly. Then here you're going to get negative 0.3037. This is your x3. Now it proceeds to x to the power of 4, which you're going to get x to the power of 3 minus with f x to the power of 3 divided with f prime x to the power of 3. Then you substitute x to the power of 3 is negative 0.3037. Substitute inside fx and f prime x, you're going to get negative 0.043 divide with 4.7063. Then the answer you're going to get is negative 0.3062. 28. Okay, and then say continue. You have x to the power of 5 equal to x, it's not x to the power of 5, x5 is equal to x4 minus with f prime x4 divide with, f x4 divide with f prime x4. So substitute 0.3028 minus with, then you substitute inside f x and f prime x, you're gonna get the numerator negative 0.001 divide with 4.6975. Then you're gonna get the answer equal to negative 0.3028, which if you realize, right, this one is similar with this. x4 and x5 is the same. So since we already got two successive approximation that has equal value by right, at the the last two iteration that we have the same value of x, then we have to stop there. So that value that is repeated twice is actually our root that we want to find at the final one. So you can write the root is negative 0.3028. That is the answer for this question. Okay, that's it for question 4. Okay, thank you.